Hello humans, I'm Mr. King. Alright, hi. Welcome back to my channel. Long time no see, boys and girls. Alright, so now we are going to discuss this past year paper, February March 2023 paper 42. Alright, let's go. See Q1 about air and water. So what is the gas that is found that contributes to global warming? Global warming, greenhouse gas. So carbon dioxide. And one more thing is here, in this case, answer it cannot be methane, even though methane contribute to global warming. Why? Because as mentioned here, in the clean, dry air. So answer it can only be carbon dioxide. So next, percentage of nitrogen in the air, about 78%. And then name the substance that can be used to remove sulfur dioxide. So you see first, what is sulfur dioxide again? You see sulfur, non-metal. Non-metal oxide, acidic oxide. So how can we remove acidic substance again? Remember, we always use calcium compound. So answer can be like what? Like calcium oxide, calcium hydroxide, or calcium carbonate. It can only be calcium compound. Any of that. Neutralization. So next one, name the equipment in the car that can be used to remove the nitrogen dioxide from in the car engine. So we know it is catalytic converter. Next one is diffusion. Remember, you see there are two factors that would affect the rate of diffusion: temperature and molecular mass, like how heavy the molecules are. So in this case, you see that didn't mention about temperature. So from here we know that it would be the mass, the molecular mass. Remember, the lighter the molecule, the faster the movement. So when you check on the molecular mass, isn't it? The one that is lightest, it would be CH4. Carbon is 12, hydrogen 14. Why? Because it has the smallest or lightest molecular mass. That's it. Then next one. What is the harmful effects of carbon monoxide? You can just say toxic or poisonous to human body. That's it. So next one, you see carbon dioxide is a reactant in photosynthesis. So what are the products of photosynthesis again? Pretty easy, we know it is what? Oxygen and glucose. That's it. Alright, next one. Complete the dot and cross diagrams. So which means dot and cross, isn't it? Which means you can only use dot, and cross to represent the electrons. So carbon is carbons 2, 4, oxygen 2, 6. So how do we know how many electrons are for sharing again? Based on the numbers of electrons that it needs to become stable. See 2, 4, how many more it needs to become 8? It needs 4 more. So therefore carbon it can only share 4. So oxygen from 6 to 8 it needs 2 more. So therefore it can only share 2. That's why I say carbon can only share 4 electrons, oxygen can only share 2. So let's say oxygen share 2. See oxygen 6 valence what? So share 2, 4 more unshare outside. Oxygen share 2, 4 more outside. And then carbon share 1, 2, 3, 4. That's it. So this is how it looks like. Next one. Given to you, you see some examples of group 1 elements. So name the types of bonding in these elements. See, they are all metals. Bondings in metals, they are all metallic bonding. And then given to you here, see sodium, it reacts with cold water to form hydrogen gas. And the solutions of strong alkaline. So how do we test for hydrogen gas again? We test with see, remember you can use lighted or burning splinter. Either one will do. Both are acceptable. Lighted or burning. Okay, remember, cannot be glowing. Glowing is only for oxygen gas. Okay, so result, okay, pop sound is produced. Okay, next, okay, what is the pH of solutions of strong alkaline? See, remember strong alkaline. So pH range from 12 to 14. Okay, let's say just 14. Okay, and then what is the substance that can be used to confirm that the pH, okay, is a strong alkaline? So in this case, isn't it? Okay, we have to use universal indicator. See, you cannot use what? You cannot use litmus paper. You cannot use methyl orange. You cannot use phenolphthalein. Why? Okay, because all the three that I mentioned just now, isn't it? Okay, they can only test it is whether acid, neutral, alkaline, that's it. Okay, but for universal indicator, isn't it? Okay, we can differentiate between strong and weak alkaline. So remember, weak alkaline, blue in color. Strong alkaline, purple in color. Okay, so next one, okay, write the simple equation for the reaction between sodium and H2O. Remember, you see, group 1 reacts with water to form metal hydroxide and hydrogen gas. So sodium, state symbol, solid, added into water, liquid, to form metal hydroxide equals solution and hydrogen gas. So is the equation balanced? Okay, no, it is not. Okay, so how to balance the equation? So 2, 2, 2, balance. Okay, then the name given to atoms of the same elements with different neutron number. So it will be isotopes. Okay, next, give me this. So it's given to you, remember, number at the top left hand corner, isn't it? Stand for what? Okay, the mass number P plus N. Okay, so you see, if you check on periodic table, what is the proton numbers for lithium? Okay, so it will be 3. So neutron, 6 minus 3, you get 3. So about electrons, see, this is an atom. Let me see, all atoms are neutral because they have the same numbers of protons, electrons. So atoms, no charge, 3 protons, so electrons, it will also be 3. Okay, you see, this is Li positive 1. So what's the proton number? 3 as well. Remember, okay, same elements, they always have the same numbers of proton. Okay, neutrons, 7 minus 3, you get 4. Electron, I say positive 1, means it has 1 extra protons compared to electrons. So electrons, it would be 2. That's it. Okay. So next, given, see, you are asked to look for the relative atomic mass. You see, given here, you see, the atoms with the atomic mass 6, it is 10%. Okay, the one with atomic mass 7, 90%. Okay, given it 100%. So how do we look for the average? Okay, average based on the percentage or the composition. Okay, so how do we do this? So you see, the one with 6, 10%, plus the one with 7, 90%, and then total 100%, isn't it? So eventually you have to divide by 100, okay, to take the average. So press on calculator, eventually you will get 6.9. That's it. Okay, next one, I see the drawings of bondings again. I see this is what? Ionic bond. Okay, one more thing, let me see. When it comes into the drawings of all this, isn't it? Okay, before you start drawing, okay, always remember, okay, first identify the electron arrangement first, because you need to know, okay, like how many electron shell left, or how many valence electrons are needed to be donated, or how many electrons needed to be gained. Okay, so know that potassium, what, 2881 initially. Okay, oxygen, what, 26. So potassium, you see, it needs to donate 1, okay, to become what? K positive 288, and oxygen, it needs to gain 2 to become O2 negative 28. Okay, so complete it. So you see, given here 28. So you see, we need to include one more electron shell, 288. Okay, and what's the charge? Positive 1. Same goes to this. Okay, and oxygen initially 2, 6. Okay, so 6 valence, see 6 cross. Okay, to show the initially has 6 valence what? Okay, and then it gains 2. Okay, and it gains 2 from potassium, so it has to be 2 dot, and the charge 2 negative. That's it. This is how it looks like. Okay, next one. Okay, Q3 Haber process. Haber process, it is needed to produce ammonia. So they're asking for the main source of each gas. So what's the source of nitrogen? Okay, air. Remember, okay, it can be obtained through what? Fractional distillations of liquid air. Okay, how about hydrogen? See, remember, yeah, air is not the main source of hydrogen because in the air, isn't it? What? The percentage of hydrogen is like about 0 point something percent. Okay, less than 1% is super little. Okay, so the main source, okay, hydrocarbon. Remember, crackings of alkane, or you can also put alkane. Yeah, the source of hydrogen gas. Okay, next one, given with you this reversible reaction. Okay, what is meant by by this symbol? Okay, so called delta H. So remember, the symbol delta means changes. H means heat energy. So it will be change of heat energy. Okay, given to you, see delta H of the 4 reactions, see, given to you here negative. Okay, 92 kilojoule per mole. So state why this value shows that the forward reaction is exothermic. Now, how does this value show that it is exothermic? Because it is negative. Okay, it is a negative value. Okay, negative means exothermic. Positive means endothermic. Okay, and then followed by the condition needed for Haber process. Temperature 450 degrees Celsius. Okay, pressure 200, catalyst iron. Okay, so given with this, so you see they're asking for what? Okay, the changes of all these typical conditions, okay, on the rate of the reaction and also on the concentrations of the ammonia at equilibriums. Okay, so you see first, let's look at rate of reaction. So you know that when temperature increases, it would always speed up the rate of reaction. Okay, when the pressure decreases, the rate of reaction will get decreases as well. Yeah, and we see if there's no catalyst, rate of reaction decreases. Okay, so next one, how about concentrations of ammonia? See, first, you see this is reversible reaction. They are asking about the concentrations of ammonia, see, which is on the right hand side. Okay, so first, okay, how temperature affects the precision again. So remember, increase in temperature will always favors endothermic reaction. Okay, so as mentioned here, forward is exo. So if forward is exothermic, okay, it means that backward it would be endo. And we know that increase in temperature favors endothermic reaction. So in this case, endo is what? Backward reaction what? Position will shift towards the left. So when temperature increases, position shift towards the left. So what will happen to the concentrations of ammonia? It would decrease. So decreases. Okay, so next one in terms of pressure. So know that increase in pressure favors the side with lesser mole. Okay, so now we compare the numbers of moles or molecules on both left hand side, right hand side. See left hand side, how many molecules? 1 plus 3, you have 4. Right hand side, 2. Okay, so you see decrease in pressure favors the side with more molecules. So which side with more molecules? 4, isn't it? And it's on the left hand side. So which means we know that position will shift towards the left. So when position shift towards the left, the concentration decreases. Okay, and next one, catalyst. Remember you see, Factors affecting the positions of equilibrium. They are only temperature, pressure, and concentration. That's it. Catalyst only affects the rate of reaction. So from here, you know that it has nothing to do with the change in position, and therefore answer will be no change. Hadam. Okay. So next one. Hi. So you have to explain. Okay. How increasing in temperature increases the rate of reaction. Okay, so whenever they ask about this, first you have to mention the kinetic energy of particles increases. So therefore what happens? Particles move faster. So when particles move faster, the rate of collision increases, and which eventually get particles that have sufficient energy to react. That's it. Okay, next one. Okay, see, ammonia, it reacts with acid to form ammonium sulfate. You see, ammonium sulfate is produced. So what is the formulas of acid needed to produce sulfate salt? So it will be sulfuric acid. Use of ammonium sulfate. See, ammonium compound. Okay, remember, the main use of ammonium compound or ammonia is to make fertilizer. Okay, then next one, you see, you are asked to calculate the percentage composition by mass. You see, in terms of mass of nitrogen in the compound. Okay, so the total mass of nitrogen in the compound divide the total mass of these compounds itself. So you see there are how many nitrogen inside the compound? NH4 bracket 2. So how many nitrogen inside? 2 nitrogen. So 1 nitrogen is 14. Okay, and there are 2 nitrogen. Okay, so divide by the mass of this compound. So 2 multiply what? 14 nitrogen, and then 4 hydrogen plus sulfur plus 4 oxygen. So eventually get what? 28 divided by 132. Okay, multiply 100%. Okay, eventually you get what? 21.2. See, 2 marks here, you need to show the working. Okay, you need to show the sum of the mass of the compound and also the sum of the mass of the nitrogen in the compound. Okay, remember, yeah, do not just show this and show you go to the answer. You can only get 1 mark. Okay, always show the the sum. Okay, the totals of the mass itself. Okay, so next one. Given with this, okay, alloy. So brass contains copper. So what is the another metals that present in this alloy? Okay, it is zinc. State the term given to a mixture of metals with another elements. Like what I just mentioned. Alloy. Okay, so name the properties of metals, which means that they can be stretched into wire. So answer has to be ductile. Remember, yeah, answer cannot be memorables. Memorables means it can be compressed. Different thing. If you put memorables, no marks will be given. Okay, memorables means it can be compressed. Ductile means it can be stretched. Okay, so particle responsible for the conductions of electricity. Electrons. Okay, next one, transition elements. Okay, state one other physical properties of transition elements other than high density, high strength. What else? They also have high melting and boiling point. Chemical properties other than what? Forming color compound. Okay, more than one oxidation number. What else? They can also act as catalysts. That's it. Okay. Next one. This is about what? Crystals. Okay, so you see as mentioned here. hydrated compound. Okay, it is hydrated crystal because it contains water molecule. State the term given to water molecules that present in hydrated crystal. So what is the term called again? Remember, it is also called water soft crystallization. Okay, and what is the colors of hydrated copper 2 sulfate? Yeah, it is blue in color. Okay, hydrated. Remember, copper 2 in the presence of water, it is always blue in color. And somehow this is also the substance that can be used to test for the presence of what? Water, isn't it? Anhydrous copper 2 sulfate are white in color. Yeah, in the presence of water become hydrated. From white, it turns blue in color. Okay, next one. Formulas of hydrated copper 2 sulfate. So how do we write the chemical formulas of hydrated compound again? So copper 2 sulfate, CuSO4. Put dot followed by H2O. See, in this case, right, see, they didn't mention like what is the ratios of copper 2 sulfate to H2O. Okay, so we can just do it this way. Okay, no need to mention about ratio. Okay, just use SO4.H2O. It is more than sufficient. Okay, next one. Okay, state the class of oxide to which copper 2 oxide belongs. See, copper 2 oxide, metal oxide. Metal oxide, they are basic oxide. Yeah, and state the meanings of the Roman numeral 2 in the names copper 2 oxide. Remember, it represents the oxidation state. Okay, or you can also say the charge numbers of the elements. Okay, so next one, mole calculation. So you see, you are asked to look for the mass of 0.2 moles of this. You see, you are asked to look for the mass itself. Okay, so in terms of mass, what's the formula again? N equals to mass over molar mass. Given to you here, 0.02 mole. M divided by, so what is the MR of the compound? So copper, based on periodic table, you get 64, and then NO3. So everything is multiplied by 2, like nitrogen, and 3 oxygen. Okay, so 0.2 equals to M divided by 188. Okay, so eventually we get 3.76. Okay, so next one. You see, they actually bold this for you. The total volumes of gas. Total volumes of gas, okay, that is produced. So you see, if you refer back to the equation, isn't it? Okay, so you see, if you look at the product side, see, these are the gas produced. So which means you need to look for the sum of both of these gas. Okay, so you see, given to you, this is 0.02 mole. Okay, so how do we know, okay, what are the numbers of moles of nitrogen dioxide and oxygen gas produced? Remember, compare the moles ratio. See, what's the ratio? 2 to 4 to 1. If this is 0.02 mole, so the moles of NO2, it would be 0.04 mole. Okay, ratio 2 to 1, so it will be 0.01 mole. Okay, so what's the formula again? N equals to volume divided by 24 dm3. Okay, volumes of NO2, isn't it? What do you get? 0.04 equals to V over 24. So V, you get 0.96 dm3. Okay, for O2, 0.01. So volume, you get what? 0.24. Okay, so you sum them up, 0.96 dm3 plus 0.24 dm3. So eventually the total volumes of gas produced, it would be 1.2. That's it. Okay, be careful. Yeah, you see, they actually bold it for you. Okay, total volume of the gas produced. You see, clue is given here. Okay, these are the gas produced. Okay, so next one. Okay, write the symbol equation for this reaction. See, aluminium reduced copper 2 oxide. Al plus CuO displacement reaction, member, aluminium group 3. Al2O3, okay, plus copper. Okay, balance equation. You see, right hand side there are 3 oxygen, put 3, 2 aluminium, 3 copper. That's it. This is how it's balanced the chemical equation. Okay, and then next one, organic chem. Okay, why members of a homologous series have similar chemical properties? Okay, because they have the same functional group. Let me see. Functional group is the one that decide their chemical properties. Okay, so homologous series to which propanoids belongs? Okay, carboxylic acid. General formulas, okay, of carboxylic acid: CnH2n plus 1 COOH. Okay, so you see propane 1O has an unbranched isomer. So what is this isomer? Remember, isomers of alcohol, right? Okay, based on different positions of the OH. Okay, so propane 1O means the OH attached to the first carbon. So isomer, it could be propane 2O. Okay, enjoy it. See, propane, how many carbon? My enormous penguin, 3. Okay, so 3 carbon. OH in the middle, and then the rest, they are hydrogen. So this is how it looks like. Okay, so next one, this is what? Cracking. Okay, so you see, cracking, okay, so it's mentioned here, propane and propene can be produced. Okay, so what's propane? Okay, C3H8, and propene C3H6. Okay, so it's mentioned that okay, it produces both of these products. So, and followed by one more product. Basically, we just balance the equation itself. So C3H8, C3H6. So balance equation. So how many more carbon we need? C4H 8. Okay, that's it. Okay, what is this called? Cracking. Ta-da! Okay, next one. See, propane, okay, forms polymer called polypropane. So you are asked here, you are asked to draw polymers, okay, that show 3 repeat units. Okay, so how propane looks like? So as you know the initial, right? Okay, propane, it looks something like this one. 3 carbon. Okay, so remember, alkene, it forms polymer by breaking the double bond. Okay, so you see these 2 carbons are joined in double bond. So which means when the double bond is broken, only these 2 carbons will get affected. So before you start drawing, isn't it? Okay, we have to rearrange everything. So we can bring this carbon down. Remember, you need to show it clearly that the bond is joined between the carbon. C to C, then only you put hydrogen at the side. Okay, if you do it this way, 100% marks to be deducted. Think about this. Okay, because what is if you do it this way, isn't it? So the bond is joined between carbon, it is joined to the H, or it is shared by both carbon and hydrogen. Okay, so we know that the bond is actually joined between the carbon. Okay, and then only you put hydrogen at the side. Okay, please think about this. So break the double bond. Extend. Okay, so you see 3 repeat units. What? So second repeat units, and the third repeat units. Okay, and you do not need to put bracket anymore. Okay, when you are asked to draw a specific number to repeat unit, right? Okay, you do not need to put bracket anymore. Okay, and always make sure that you always make sure the drawing, okay, both the ending, okay, both the end, right? Okay, always end with ascending bond. Okay, because this is polymer. It is to show that it is still joining with some other monomers. Okay. Next one, state the test of polymerization that takes place. Okay, so what is this called? It is called addition polymerization. Only alkene can undergo addition polymerization. Okay, next. See, propanoic acid reacts with sodium carbonate to form a salt, acid alkaline reaction. So name the salt produced. So it will be sodium propanoate. Okay, and what is the formulas of the anions, which is the negative ions? You see, propanoic acid. So what's first? What is the chemical formulas of propanoic acid? Okay, C2H5COOH. Remember, okay, acid will always give away hydrogen ions, and it is always the H in the COOH to get removed. So the negative ions will be C2H5COO -1. Okay, so next one, propanoic acid forms an ester when it reacts with ethanol in the presence of catalyst. So this is about what? Esterification. So what is the catalyst to use again? Concentrated sulfuric acid. Okay, the ester produced, see, remember the naming part always start with the alcohol part, then only followed by the acid part. So alcohol part, ethanol, ethyl propanoate. Okay, and how do we draw this? Okay, always start with the function group COO. Okay, alcohol part attached to the O in COO. You see, alcohol part how many carbon? Ethyl 2 carbon. So 1, 2. The rest hydrogen. Propanoate 3 carbon. 1 carbon here, 2 more carbon. The rest hydrogen. Okay, that's all for this paper. Alright, so hope that this is helpful for you guys. If there's any questions, you guys can always drop your questions in the comment part. Thanks. Remember to like the video and subscribe to the channel. See you again. Bye.